So let's start pyramid today. Projection of pyramids. Before going to projection of pyramids, we'll see which are the different parts of the pyramid, because in the problem they mention the parts. Okay? So in that case, so this will be the base of the pyramid. So depending upon the polygon that the base will going to have, they're going to name this pyramid. If it is a triangle, then they'll call it as triangular pyramid. Right? So if it is a square pyramid, it's a rectangular pyramid. If it is the base is a pentagon, then pentagonal pyramid. So then we're going to have hexagonal pyramid. So the pyramid will be something like this, where in case of the prisms we had actually two end faces, similar end faces of polygons. So then we're going to have that longer edges, whereas in this case only one polygon, that is the base, they call it as base. Then from all the corners of that polygon we're going to have these longer edges. They're going to meet at a point called as apex. So again we'll see that these longer edges, because they are going to incline with the base when it is resting on its base, they call it as inclined edges. So the lateral edges or the longer edges, what you call in case of the prisms, in this it will be called as inclined edges, whereas these are called as base edges. So base edges, inclined edges, or longer edges also you can say. Then they are going to meet at a point called as apex. So this is the apex, where one end of the axis will be here, the other end will be at the center of the polygon what you are going to have in the base. So the center of the base to that apex, that forms the axis, a line joining from the center to the apex. Okay, and all lateral surfaces are now will be triangles in case of the pyramids. So triangular faces, they call it as triangular faces in this case, whereas in case of the prisms we used to call rectangular faces, because so the lateral surfaces were rectangles. So you can have a similar condition, something like what we saw in case of the prism. So where the axis resting on its base on HP. So in that case, if we have, say, this is the page below this XY line, if that is HP, so then the base resting on HP. So in that case, similar to the prisms, you can say whenever the pyramid is resting on its base on HP, so it can rest in any different position. So then you have to name exactly what is the position. So when it is resting on its base on HP, the axis will be perpendicular to HP, whereas it will be parallel to VP. Right? It will be parallel to VP. The axis will be parallel to VP and perpendicular to HP. The same way you can have the axis perpendicular to VP and parallel to HP. So when it is having its base in VP, the axis will be perpendicular to VP and parallel to HP. So these are the simple position. Again, based on the position, you're going to have a different views. The views goes on changing. In that case, you have to define exactly the position of this pyramid with reference to HP and VP. The reference, in that case, no, the reference will be the edge. Okay. So if I keep the solid something like this, a pyramid something like this, then I can say one of its base edges, because there is no rectangular surface, and all these, even the triangular faces, are going to incline. So you cannot say that one of its rectangular surface is perpendicular to VP, as we said in case of the prisms, whereas in case of the pyramids you have to refer to the base edges. So if you have a triangular pyramid, then I will say I can keep actually the pyramid in different positions, right? So that is something like this. If I keep in this way, I can say that the triangular pyramid of base edges of say some 20 mm and the height of the axis of 50 mm is resting on its base on HP such that one of its base edges is perpendicular to VP. So one of its base edges is perpendicular to VP. So then this is the position, and you can say that is towards right, and again even in this case also it is perpendicular to VP. One of its base edges is perpendicular to VP, but you can say it is towards left and it's towards right in that way with reference to the observer. If I keep in this way, then the view again changes. So I can say one of its base edges is parallel to VP and is nearer to VP. So then the view again changes if I turn like this. Even here you'll see that one of its edges is parallel in both the cases, this way or this way. So but I can differentiate this now, saying that one of its base edges is parallel to VP and is nearer to VP, whereas this is, you can say, one of its base edges is parallel to VP and is nearer to the observer, or it is away from the observer, nearer to observer or away from the observer. Then I can I can have a different position. So these are two positions what I said. Then I can go for a different position where one of the edges can make any inclination apart from parallel and perpendicular. It can make any inclination. In that case also we can mention that triangular prism of any prism I'm going to have a different position. So then I can say one of its base edges of that pyramid, sorry, not prism, pyramid. Now one of its base edges of the pyramid is inclined at some degrees to VP. So one of its base edges of the pyramid is inclined at some 30 degrees to VP or 45 degrees to VP. In that way I can say towards right, or I can even give the inclination. So 10 degrees, 20 degrees, 30 degrees. So any degrees with VP towards left or towards right. In that way I can define the position, exact position of this pyramid. Then I can go for drawing the views. I'll just go for drawing a set of views. Okay. For all this we'll see how we can represent all the views in the top and front view. So I'll go with the triangular pyramid. So when I go for drawing the triangular pyramid, so locate the center. So this becomes the apex O, and O1 is the center of the base. So that where the axis will be. So then I can see that, see, when I'm looking from the top, I can see all these inclined edges. The length of the inclined edges that will be apparent, but I can see the edges. Whereas in case of the prisms, they were actually perpendicular. I was looking like a point, and that views were, when I projected, it was like a point because all the longer edges were perpendicular to HP, and I was not able to see that. Only I can see the end point. So because it's perpendicular, only a point. Even though it's a line, it was looks like a point. Whereas here we can see actually all that inclined edges. In that case, from all the corners of this, the base, what you have, whether it's a square or a pentagonal or anything. So we'll see that. So we're going to have from all the corners, so the inclined edges, they're going to meet at this apex, and we can see all that inclined edges, right? So in that case we can go for drawing all that inclined edges, something like this, using HB, because that are visible edges, can go for marking in this way. So then this is ABC, the base, so OO1, then OA, OB, OC are inclined edges, whereas AB, BC and C are base edges, are shorter edges. Anyway, they call it as base edges. So the front view for this will be just projecting this, how exactly it looks when it is resting on its base on HP, something like this, a triangular, triangular pyramid. So this is the view. If this is HP, then this is the view. We can see that view, something like a triangle. Okay. So the procedure to get that is just project the axis, draw the axis to a length equal to the axis, the height of the pyramid. So axis length will be the height of the pyramid. Then that becomes O dash, and this is O1 dash. Then we will going to join to this edges A dash B dash, and say this point is C dash. Just join them using a thick line, and the base will be a dark line. So there should be a difference between the base and this XY line. So draw XY line using a medium thickness. You can use actually H pencil, but as for all this you can use HB pencil. Even the axis line will be drawn with the medium thickness, so you can use H pencil for that. So all these projectors and construction lines should be very thin. I'll go for the next position. So this position is nothing but one of its base edges. One of the base edges of a pyramid is parallel to VP and is nearer to it. If we go for a triangular pyramid, then so this is the base edge which is parallel to VP and nearer to it. Whereas I can have one more view, something like this. So one of its base edges is parallel but is nearer to the observer, or it is away from the observer. Then locate the center by bisecting any two of the sides. Then I can see all that inclined edges, draw them. So in case of the prisms, there was no lines actually. There were no lines in the end face. That's a plain figure. Whereas here you can see that inclined edges. So then if this is ABC, O1, so then say this is ABC. So these are the positions where you can say one of its base edges is parallel to VP. So I can differentiate these two by saying that edge which is parallel to VP is nearer to VP, or this is away from VP, or you can say it is nearer to the observer. So one of its base edges is parallel to VP and is nearer to the observer. So this is away from the observer, but it is nearer to VP. In that way, you can name the position. So we'll just go for projecting the axis. So to height equal to the given length. So go for completing this view. So this is A dash, B dash, and this is C dash. So OC, this is O and O1. OC is in the front, that is visible. Then I can go for making that. So this edge OC overlaps the axis. In that case, I need not try and draw the axis. It overlaps because you're going to draw with a thick line. Anyway, that overcomes. Okay, so this is the view. So in this case, we'll check out how will be the view. If you project, so go to that axis. So anyway, this is the axis height. Then join them to that apex, what you call, okay. So this is A dash, B dash, and this is C dash. So there is an axis here, but there is also O1, that is OC invisible edge overlapping in this behind that. Okay. But always we'll go to give the preference to the edges because you have to imagine the solid with edges. So then you need not worry about the axis. Just go for drawing a dotted line to represent that OC, whereas O1 O is actually, can you just imagine? So the preference will be given to the edges. So in that case, so this is the dotted line, invisible edge, because I cannot see this edge which is on the other side when I look at, okay. So that becomes the invisible edge. So this edge will become invisible edge when I'm looking in the front. Whereas in this case, I can see this edge, even all these three edges. So made with a thick line. Any other inclination, I can start saying that one of its base edges is inclined with some degrees with VP. Then I can construct any polygon in this and I can project that. So I'll go for say a square prism in this case. Okay. We'll see how exactly can imagine any pyramid. So sometimes because I taught prism previously, I'm getting only the prisms. Saying many times prisms. Okay, so just sorry. This is the axis. If this is say A, B, C, D, O1, then this is O1, O1. Depending upon the height, I can move up the axis. then I'm going to join to this outermost edges are visible. I just join to this outermost edge, that is C dash and A dash. We'll check out whether this B dash is in the front. Okay, so I can see that. So this is B dash, I can see that edge, so it is visible edge, whereas this I cannot see. OD, that becomes a dotted line. Then we'll go for dotted line, equally spaced, equal length line. There should be a difference between this line and this line. A big dash and a small, see, small, big, whereas here they are equal lengths, so equally spaced. So this is the view whenever we have. So in this case I can say one of the base edges of the pyramid is inclined at some degrees, 30 degrees to VP, and is towards left. In the same way I can have different positions. So in the same way, even in, I can keep the base in VP. So in that case, I'll just go for drawing here. I will just, for one of the view. So even in that case, I can keep actually the solid, the pyramid like this, having its base in VP. I'll say that one of its base edges is perpendicular to HP, one of its base edges is parallel to HP, and nearer to it, nearer to HP. In that way, the same condition what I said here, perpendicular to VP, this is parallel to VP. Here I can say perpendicular to HP, parallel to VP, because the base is in VP, whereas here base is in HP, and I'll say one of its base edges is perpendicular to VP, whereas here I can say one of its base edges perpendicular to HP. In that way, you're going to have a completely reverse. So even you can have base in that case. So sorry, I'll just project the axis. So once I get the axis and the height of the solid, then I'll go for joining them like this. So need not project up to this, only up to here, right? So this is ABC with all dashes, because this is the front view, O1 dashes, so this becomes O and O1 dash. So this is C, O1, okay, C, B and A. So A I can see, so B will be in the bracket. So for this A dash, B dash, C dash, O dash, O1 dash. So same thing if I project. So for the height equal to the axis height, because this edge is visible, it coincides with the axis, I can just project with a thick line. I'll get that height, then I can join all these edges. So this is O1, A, B, and this is C. Similar to this, see, completely reverse of this. One of its base edges is parallel to VP and is nearer to it. And when I look from the front, I'll see this. So in this case, one of its base edges is parallel to HP. When I look from the top, for the top view, I can see all these three edges. Whereas here, in the front, I can see all these three edges. The same way, if I keep this is in VP, so if this is VP, if I keep this in VP, so that is your view. So if I keep in VP, I can see all these three edges, right? Okay. So all these three edges. So same view, same thing, okay, completely reverse. So this will be here and this will be here. So anyway, these are only the basics. You're not going to get any problems of that particular type. You're not very much if you understood to place the position, because this is very important. This is the basic, the first step to keep the prism, pyramid or any solid pyramid on HP. So based on different positions we have to keep, okay. So different conditions you have to position this, the pyramid, something like this, or whether to have a corner on the right side, based on all that, okay. So I'll go for now a pyramid inclined to one plane and parallel to the other. The pyramid is inclined to one plane and parallel to the other. This is nothing but, say, when I keep the pyramid on HP, so the axis will be perpendicular to HP and parallel to VP. Then I can, keeping that parallel to VP, I can just give the inclination to the axis with HP. So if I keep the solid on HP, I can give the inclination to HP. In that case, whenever you have any problem saying that its axis is inclined at some degrees to HP, then you have to keep that pyramid or any solid, whether it's a prism, cylinder or cone, on HP to satisfy the first inclination with HP, the axis inclination. So you have to keep the solid on HP. And how, that depends upon the problem again, whether to keep in this way or like this, to have a base edge on the right side or corner. So in that case, when I bend, you can observe here that it's going to rest on this base edge. In that case, they are going to mention in the problem saying that it's resting on one of its base edges on HP such that the axis is inclined at 30 degrees to BP. So I can create a problem now. A triangular pyramid of 30 mm base edges and height of 100 mm, some say 60 mm or 60 mm, resting on one of its base edges on HP such that the axis is inclined at 30 degrees to HP and parallel to VP. Draw its projections. So only one inclination, inclined to one plane and parallel to the other, or inclined to one plane VP, right? Okay, if this is VP, right? Okay. So then I can say inclined to one plane and parallel to HP, inclined to VP and parallel to HP. So in this case, I can say inclined to HP and parallel to VP. So based on that, I can go for this. So if I'm looking at VP, it's different. Okay. So in that case, this is the one where axis inclined to HP parallel to VP. The front view, it looks like this. See? So if this is HP, the base is in HP. So axis is parallel to VP and axis is perpendicular to this plane because its base is resting in HP. Then if I incline, so it will going to rest on this edge, the base edge. Okay. So then I can tilt about this edge. So it will going to rest on that edge. So other end points will move up. So then I can say it's resting on one of its base edges on HP and axis inclined to HP, keeping it parallel to VP. So I'm not changing the inclination, something like this. So keeping it parallel to VP, I'm just inclining the axis with HP. So same thing when I look at on the top. So it looks like this. So this was in the front, how it exactly you look at. I'll go for now a problem. We'll see how we can draw that. So in that case, you can have actually even the corner position. So in that case, you're going to have a corner position. When I bend towards right, it's going to rest on the corner. So in that case, the problem will be something like this. Any pyramid, a triangular pyramid of base edges 30 mm and a height of 60 mm is resting on one of its base corners on HP such that the axis is inclined at 30 degrees to HP and parallel to BP. So then I have to keep the base having a corner on the right side so that when I bend towards right, it has to rest on the corner which is on the right side so that I can give the inclination to VP, any inclination. So in that case, they can give you the axis inclination or the base inclination, in that case when it is resting on HP. So the axis inclination, when the axis inclines, base also goes on inclines with 90 minus that axis inclination. So then I can give reference to this inclined edge also, we can say. So in this case, the sentence what we can change is resting on one of its corners of its base on HP such that the inclined edge, that's the longer edge, okay, longer edge, an inclined edge containing that corner is nothing but this, the inclined edge or the longer edge containing this corner which will going to rest on HP. He says that is perpendicular to HP. So see, previously it was inclined when it's resting on its base where the axis was perpendicular. When I turn, the axis will going to incline, even the base will going to incline with this angle, whereas this becomes perpendicular to HP. Or they can give you any other inclination with HP also. They can say the longer edge containing that corner is inclined. Or when you say something like this, so you can say longer edge completely resting on HP. This is inclined, perpendicular, any other inclination. So with reference to that inclined edge. In that case, we'll observe that even the base and the axis goes on inclining. So in that particular problems, they can give you the axis inclination, base inclination, or something like this. Longer edge containing that corner, or the inclined edge containing that corner is inclined. The same case, if it is resting on one of its base edges, even then you can have a different condition saying that if this is HP, the base is in HP, the axis is perpendicular to HP and parallel to VP, it's parallel to VP. Now when you give the inclination with HP, keeping it parallel to HP, the axis inclination, we'll see that. Okay. So this, even the triangular surface is inclined now with HP, that you can say it is perpendicular. The triangular surface containing that edge on which it is resting, you can say that is perpendicular to HP, or perpendicular to both HP and VP, because it's already perpendicular to VP, so it's inclined with HP, that you can make it perpendicular. So by rotating like this. So inclined, right? Okay. So the surface is inclined, then you can make it perpendicular. So any other inclination, even you can say the triangular surface containing that shorter edge on which it rests, the base edge on which it rests, is inclined at an angle, some angle with HP. So otherwise you can say when you completely make it to rest on the triangular surface, we can say it's resting on triangular surface on HP. So that way you can give any inclination rotating like this. When you are looking in the top, when you are looking in the, this is, okay, you look from the top. This is when you are looking in the front. I'm turning now. So this is vertical plane, observer is standing here. So this is front view, perpendicular to the vertical plane. So any inclination, in that case the base or the axis inclination, or this inclination of this triangular surface or the longer edge can be given. So the same thing will be continued in that problems where you have axis inclined to both the planes. We'll go for one or two problems of this type. One resting on one of its any pyramid, the same procedure. I'll just go for triangular pyramid because minimum number to draw. So to understand you people, but I want you to try with other pyramids, pentagonal and hexagonal pyramids. A, B, C, O, O1. You project. So where the axis will be perpendicular now. So this is the view. O, O1 dash, C dash, A dash and B dash. So B you can see, A will be in the bracket. So this is the base. So axis is now perpendicular and parallel to VP. So perpendicular to HP, that's why it's a point here, and it's parallel to VP, that's why it's the true length. Then the inclination, when they say it's resting on one of its base edges on HP and the axis is inclined, then I can go for making the base 90 minus the axis inclination. Or they can give you that. So in that case, if say axis is inclined at 30 degrees, I can go for inclining the base at 90 minus that 30 degrees. So that is at 60 degrees. When I take this length and transfer the axis here, so then axis makes an angle of 30 degrees. This will be 60. When you dimension, you can say this is 30 degrees to HP. Same length you transfer here, right? Okay. So this is the length, total length. Okay. So then we have the height of say 60 mm. Locate that height. Okay. So now to represent the axis, big dash, small, and big. Go for completing the same view which is available in the previous step. So O dash, O1 dash. So this is A dash and B dash. So A dash, B dash is nothing but the edge, the base edge which is now resting on HP. So in this position, so just project this, draw locus. So So look at the point A, this is B, this is C, even the O also I can just project because we require that O1, and also this is O. So whenever you have in pyramids, because there will not be two end faces as in case of prisms, so where the end face which is nearer to the observer will going to make it all the edges of that end face which is nearer to the observer with a thick continuous line. Then we used to draw all boundary edges with thick lines because all boundary edges are visible. Whereas in this case you will not be having two end faces. In that case you find out the end of the axis which is nearer to the observer. If the apex is nearer to the observer, you cannot see the base completely. In that case, some of the edges should be a dotted line in the base. If this base end is near to the observer, is nothing but the base will be visible. See, compared to this apex, the base end is nearer, is nothing but you can see that base completely. So then you can mark all that base edges with a thick continuous line. Whereas in this case, so this is something like this. So where you cannot see the base completely, only some edges. So if it is other pyramid, you cannot make out some of the edges. Some edges will be dotted. We'll see this becomes only 3 edges, so 2 you can see. So the third should be a dotted line. So you cannot draw all the edges with thick line here. Okay. So only if the base is near to the observer, you can go for drawing all the edges with a thick continuous line, visible edges. So in that case, we go for drawing all the outermost boundary edges in case of the pyramid. So then if this is the outermost end and the other end of this OC, the inclined edges, is visible, the apex end, and this is the outermost end of the edge, so that is visible. So visible edge, because this end is outermost point, so if that is visible, and if the apex, the line joining to the apex is visible, is nothing but, if we can see the both the ends, is nothing but you can see that completed. Or you can see here, cross check that. See, you can reach all the points of this OC, so that's the visible at topmost edge. So when you bend, so this is the topmost edge. Okay, so when you bend like this, so on HP, so this is the topmost edge, that OC, you can see that edge. So then that will be the line. So then this becomes the triangular lateral surfaces. So on the complete area, the boundary now are 2 surfaces. So where on the surfaces you cannot find any edge, you should not be any, and there shouldn't be any edges. Then this is nothing but the invisible edge. The line of joining this AB should be invisible edge, because that will be actually below the surface, right? So then you go for marking that with a dotted line, equally spaced, equal length line. So this is whenever you have any pyramid resting on its base edges on HP with its axis inclined to HP and parallel to VP. The same thing if I go for drawing in this way, we'll see what will be the difference.